this demonstration, I'm going to write a program to print out data on a binary file. I write here by file for binary file in a program. In this program, I will create first a binary file, and then from the binary file, I will read the data. So I start with the implicit none and store some, declare some variables, say a, b, and then a vector, say x, that can store 5 values, and then for we can use the data statement to store data to values a, b with the forward slash. So a equal to 3.5 and b equal to 10.7. And again, data statement to store values to vector to b. So b 5 times zeros. So if I print the values, so I print here value a, equal to a, b, b, and the vector x equal to x. Let's see whether everything written is correct here or not. So I save the file to the working directory. So binary file dot for. Okay, working directory. It is in G folder and the bin directory. Yes, binary file dot for. Let's compile and run and see whether it is working properly or not. B77 binary file dot for. So binary file dot exe. Okay. So there is some error. So this forward slash seems to be extra. Yes. Okay. Okay. This should be x. So compilation is successful. And now I write here my file.exe. So the values have rightfully been printed. 3.5, b is there, and x is there. Now let's do the printing on a file. So I write the file ID for the program. So open unit say 10. I have to provide a file name. So I write here binary out dot out, and the status of file is old, not old. This should be created or it should be overwritten. So I write here unknown. I'm going to use it as the as for writing the output. So on separate lines, instead of these printing statement, I write here a statement for writing the data without a format. I write here write on unit 10 that is value of A, write then as there is value of B, and write then as there is the value of X. So this file will be created. This status is written as unknown. Let's execute this program. So unknown, N is missing. This was not recognized. Unknown. Save the program and do the compilation and run. So this is as such, but the file is going to be created in our directory. Yes, this is the latest file by out. So we have got the same results. Now, instead of printing the output in ASCII format, I just save the data in another file and let the data to be remain in the binary format and do not ask for getting the output in the ASCII format. So I write here a file. So with the name say binary out, and this file must have another uh, attribute. This file should be unformatted. This is the form for it, and then here the final attribute status say unknown. So instead of this similar lines, instead of these lines, the form is unformatted. Therefore, there is no need to write the format. So I write on unit 15, write A, then on unit 15, write B, and on unit 15, write X. So on similar lines, the data will now be printed on unit 15, but it will be printed in unformatted state, which means that is not going to be converted into the ASCII format, which is readable by human beings. Now the data would remain in the machine readable format. So I recompile the program. There are no errors, which means everything is written correct with respect to Fortran syntax. So everything is same, but unit 15, something is going to be written. So binary out. If I open that file, binary out, it is the latest file. Some strange things will appear to us. So many different things, but it contains the data as the data available in the binary dot out. So binary dot out was overwritten because the program was run again. Now the file binary out, bin out, and by out dot out, they contain the same data and with the same computer format. So I can read the same data from the binary out, from this file, just like I read the data from this file. So in this file, I have a real value in the first line, I have a real value on the second line, and five real values in the third line. So now I will write lines to read the data from the file binary out. So for the time being, let's make these lines silent. I do it in the same program. I comment this line, and now I'm going to read the data from the binary file. Instead of writing it in the separate program, I use the same variables. And instead of giving data values, or we can, it's good to define other variables. So I write real AA, BB, and a real vector that can store 5 values. So now I'm going to read the data from the binary file in this program. So file has been created. It is on unit 15. Or I think it's better to change the unit number. Now unit number 20. Unit 15 was to write. Now I'm going to read the data from unit 20. We know if we like to read the data from the file where we have data values written in ASCII format. So similar lines of program would be written to read the data from this file for which the data is not available in ASCII format. So I write here now read from unit 20, which is a binary file, and read a value, and then read unit 22 like from the second line, and then read from unit 20. There are 5 values, so I write 5 unit I j, where j varies from 1 up to 5. So these values would be written with the implicit none. J has not been identified, therefore I write integer j. And to see whether the data has properly been read from the binary file, this is to read data from binary file. It was created the earlier version of the program. So I write here print data reading from binary file. So unit 20, what has been read. So to make it distinguish from the earlier got data. So I repeat these lines. Here, and instead of A, we have a variable. Instead of B, we have BB variable. And instead of X, we have Y variable. Print asterisk Y equal to Y. Okay. So reading data from binary file, the data in the bin out is now being read by the program, and the binary data was identified in unit 20. So here we go. So recompile and run. So reading data from the binary file has been successful. The way we use the data reading from the sequential file, similar way we read the data from the binary file. So it's done. So let's have a look at the sizes of the data files. So what I expect is that the binary file size should be smaller than the file in which the ASCII format data was written. So by out, it is 43 bytes. The size is 43 bytes. This is out file. This is the ASCII format file, and the bin out is 52 bytes. So for this problem, we have found it the vice versa. But it is recommended to work with the binary files if there is a large data set. In order to read the data from a binary file, we must have be very clear in which sequence the data is given. So which means the programmer who has created the binary file output is only be capable of reading the data from the binary file, because all the statements which were used to write the binary file output, they must be used in the same fashion to read the data with the reading statement.